Hello and welcome. Eitan Suez here with Solo.io. I'm a technical marketing manager, and in this lesson, we're going to discuss a new and evolving standard, an extension to the Gateway API known as the Inference extension, and we're going to demonstrate its use with the kgateway project. So what is the Inference extension? You should know that it has its own sort of portal, just like the Gateway API does too. We can take a quick peek at it. It looks something like this, and so there's material that we can review and read to familiarize ourselves with this new extension, and they're even started publishing some guides recently, and there's a little bit of a reference, but it's still a work in progress. It is an extension to the Kubernetes Gateway API, and it's designed specifically for or to accommodate LLM inference workloads. And the concern here is, how do we route efficiently to LLM workloads? And the assumption is that LLM workloads are in many ways unique and have unique requirements, and therefore demand some analysis and inspection in terms of how we should route to it, because their nature is rather different from typical workloads. And the concern is routing, right? Routing based on specific target model name and the request body can be used as maybe a means of decision making in terms of which workload we direct the request to, based on all kinds of different criteria. So the extension essentially extends the Gateway API in the way that you see through this illustration. It introduces two new LLM-specific resources. One is called the Inference Pool, and the other one is called an Inference Model. And the Inference Pool provides essentially a way of selecting or grouping compute resources that run model servers. And so you may have multiple inference pools that each sort of represent different backends, you may say, that run different models. And the inference model is really where a lot of your routing decisions are going to reside, a way of sort of selecting what model in the request body should route to what target model on the back end. So if we look at some examples, these are examples taken directly from the lab that we're going to be running in just a moment. And I just remembered I should probably press play track before we carry on. So if we look at this particular resource, this is an inference pool. The name sort of alludes to the context of the activity. We'll explain that in more detail in just a moment. But here, notice this almost reminds me or reminiscent a little bit of a cluster IP service that selects endpoints or backing workloads through a selector. And you see here the notion of a selector that's selecting a specific deployed workload. Here I call it a fake LLM, and it's running on port 8000. The inference model, on the other hand, is more concerned with matching incoming requests to the right inference pool, and so you have a pool reference there, and you also have a target model and a model name. So requests with the fake-LLM model name will match this particular inference model configuration, and the target models, think of it almost as a sort of traffic splitting scenario where we can actually target a specific model and use weights to specify what percentage of those requests should go to that particular target model, and you can specify more than one there, of course. So that's the idea. And so to get a sense for what this looks like, again, this is still early days, we're going to install this inference extension with kgateway. And we're going to deploy a fake LLM workload for the sake of saving on compute resources. And then we'll apply the inference pool and inference model that you just saw, and then provision a gateway with a route, and you'll see how the route ties to these resources, and then submit some test requests and see it in action. So without further ado, let's go ahead and launch into our sandbox. Here we are. And maybe I'll make the font size a little bit bigger there. So the first thing we need to do, we have here a Kubernetes cluster running kgateway, but without the extension. And so the first thing we need to do is apply the CRDs. Notice the version is 0.2, so it's still very much early days. This will apply the inference pool and inference model custom resource definition to our cluster. And then we'll go ahead and upgrade kgateway to enable the inference extension. That's the main sort of toggle that we need to turn on there. There's also this notion of auto provisioning the inference extension. When you create a route, you'll see that in action as well. So So I mentioned we're going to use a fake LLM. This is going to be a canned, fake that's going to respond in a manner that, or structurally in a manner that mimics what an LLM would respond, but obviously has no smarts whatsoever. So we're going to apply this workload, and the pod will be up and running in just a second. So there it is coming up. And so we've looked at the inference pool that selects this particular workload, the selector app fake LLM. If we were to look at the fake LLM.yaml, you'll see the selector would match the label. And so we're going to select that workload. And that inference pool is named fake LLM pool. So we're going to apply the inference pool. Next, the inference model again is going to basically decide that any requests with fake LLM in the model, in the request body, should be sent to the LoRa adapter A. So I didn't mention yet that this fake workload has two distinct extension models, LoRa A and LoRa B, and the idea is that we can select one or the other based on what we specify here in the target models stanza. So that's the idea. So we're going to route all traffics to LoRa A, basically, is what we're going to do here. Notice we also specify criticality, which can also factor into a decision making that pertains to routing. If it's a very critical inference model, then we would prefer it over a competing one. So let's go ahead and apply that, and now we'll provision a gateway. Now if we look at our gateway, there's nothing new here. It's the gateway class name is kgateway, and it has a single listener on port 80, and so we can go ahead and apply that. And then we have to configure a route. Oops, pardon me. Configure a route to what? This is the interesting part. This is where everything sort of ties together. If you look at this HTTP route, the backend ref is actually the inference pool that we just created. And the inference extension, which we'll be running, will essentially look at the request and look at how the pool was configured with the inference model and decide to send requests to LoRa A. That's how that works, more or less. So if we go ahead and apply this route, now what happens at this juncture is we'll see a pod come up named an endpoint picker, which is essentially the extension. And we'll wait for that to be up and running, which it is. And so now we can essentially test requests. We can capture our gateway IP address, and we'll send in a request. Let me go ahead and copy and paste it first before we run it. So we'll send in a request to a V1 completions endpoint, and we're going to send in, notice the model name is fake LLM, and there's a prompt, but obviously that's not going to matter since we don't have any smarts in our fake backend. And then we get a response, and notice that the response comes from LoRa A, right? The extension model that we specified in the inference model. And so if we were to, for example, edit our inference model and maybe specify LoRa B, or maybe do a 50-50 split between A and B. We'll just stick with LoRa B here. We can then submit another request, and you'll see that the request will get forwarded to the alternative model, the LoRa B model. Oops, that's the wrong command. Here we go. And this time the response is coming from the extension, the LoRa adapter B and not LoRa adapter A. So the extension is doing its job of routing based on, and notice that the request specified the model name that matched the selector in the inference model resource that we specified earlier. All right, so that gives us a little bit of a taste of this sort of up and coming extension. It's still early days, as I mentioned. If we sort of go back here to our deck, there's a couple of closing comments I want to make. One is this is very new and still very much evolving and not yet production worthy, but we wanted to show this working with kgateway. So we've got some early versions of this integration working, and as organizations deploy LLM workloads in their compute environments, this extension will address routing related concerns associated with LLM workloads. So that's the whole idea behind this extension. All right, thank you for your time, and I hope you found this useful. We'll see you in the next lesson.